Okay, good evening, guys. Myself Nagamadava. Today we are going to discuss on transportation. So, first of all, I want to introduce myself. My name is Nagamadava Korlakunta. I am present. Currently, I am in my last semester of my masters, pursuing in UNH. So, at last year on March, I completed my FA exam. Since June, I'm teaching this my fifth batch, and I welcome all of you, and I appreciate all of you. You're thinking of taking FE exam. This is your first step towards your success and your professional career growth. Um, and make sure you utilize every opportunity here, learn well, and understand the concepts well, which will not only help you to pass your FE exam, it also help you in your careers too. Even if you're doing your job in transportation or geotech or some in structures or construction anywhere, these all concepts are the basics. You daily run through these topics, underlying, maybe knowingly or unknowingly, you're gonna see these concepts in your jobs too. So make sure, yeah. And I want to let you know few things before start our topic. So FE is all about time, not the concept. Um, yes, you need the concept, you need the solutions, how to formula, how to do everything, but it all about your time. You have you have 2 minutes 54 seconds for each question. So in that 2 minutes 54 seconds, you need to read your question, understand your question, and search your formula in handbook and write down or calculate that in your calci and pick the correct answer. Beware of units always. So these are the five important steps you need to go through and answer a question in your FE. So FE is all about your timing. Make sure you practice well a number of questions to get the timing correct. And most of, like, I can say 30-40 questions in your paper by using simple tips and understanding that question well, you can eliminate few choices or options easily, and you can get the answer without solving also. So in this class or training or coaching, whatever it is, you're gonna learn those tips and tricks how to solve a question easily in stipulated time, not beyond the time. Okay, so if you have any questions while I'm like saying anything or any concept or any formula, if you don't understand anything, stop me there and ask me. I'll try to clear the doubt itself. If you didn't understand that, ping me in WhatsApp, or after the class you can stay in the class. I'll try to explain once more in a different way, what in which way you gonna understood that one. Okay, so, and next thing, I believe in a class there
काम नहीं हुआ तो
should,
मेरे को गुस्सा आता है। वो काम हो जाना जल्द
shouldn't
का जल्दी, टेंशन चले आती मेरे घर, ठीक है।
in class. I personally believe class should be in two way, not in, like, I'm teaching, you are listening. Not, I don't prefer in that way. I pick someone randomly for answering few questions or just to talk on a situation. So most of the times transportation is all about situation, like it about imagining something that you go through in regular day-to-day life. So I'll give such type of funny situations where you need to think and answer in a good way, such that we can extract some concepts, formulas, and the ideas how the formula is working, this concept is working, why we need to, why this is important, like stopping side distance is important, or curves are important, or like that. So in that scenario, in my personal belief, the class should be in two-way. I pick someone randomly and ask you a few questions. If you don't know anything, don't worry. We are here to help, and no one here is perfect, and including me, I'm also learning in day-to-day life. So don't think like that. In one batch, one of my student, I called him in the first class, and he never attended my class. I was just wondering why he is not attending the classes, and then I texted him, "Hey buddy, what's up? Are you okay? You are not attending my classes." He replied, "You are asking me the questions." Dude, if you don't want to answer, just tell, look, like, if you don't want me to ask you question, it's okay. Or if you don't know the answer, it's okay. Or I just want some answer, even it is dumb, it's okay. You're gonna learn. Don't skip the class, okay? One thing that, and secondary, before actually commencing into our class. And next thing, here you can see our page Bhavanam C2C in LinkedIn. You can all follow that page. You can see some hiring things, and job notifications, etc., or some related to FE. You can follow me also in the LinkedIn. It's my, it shows Nagamadhava Kologunta EIT. You can follow me over there, and please be active in LinkedIn, not for only FE, for your job search. If anyone looking for jobs or something, wasting our time in Instagrams or Twitter space with fanverse or something, it's better to follow LinkedIn and see some of our guys what they are doing really. So it helps you in your career. And we have one WhatsApp group which is related to job postings. If anyone is not in that group, let me know in the WhatsApp, in that group. I'll send that link also. So until now, we done with whatever the necessary things we need to think of, and now we'll jump into our actual today's topic, transportation engineering. And yeah, transportation engineering, which you, from this topic you can expect anywhere between 9 to 14 marks, but in generally 11 marks are coming from this transportation engineering most of the times. So sometimes it may 10, or it may be 13, 14 also, but most of the times it is like 11 marks. So from 11 marks from 110, total of 110 marks, it's 10% of your syllabus. So now you will understand how much important this subject is. And believe me, whatever you learn in your bachelor's or master's are pretty much enough to cover all these topics. But you need to understand that bachelor's or master's are precisely um, focused on how to solve the each and every step and understand the whole other concept. You're gonna, if you are solving some question in horizontal curves, you're gonna see some big tables, and each and every where you're gonna solve, how this came, this angle, what is this angle, what is this degree, what is this radius. You're gonna see everything. But coming to FE, that's not the case. You just have some question, it's just simple equation. You need to find that, and based on your formula and all, with checking correct units, you need to solve the question. So that's as simple as that. But you need to understand the background to do that question correctly. Okay, so it's all about 5 topics. And you have geometric design. In from geometric design, you may expect 3 questions I can say 3 questions easily from that geometric design itself. Why? Because geometric design is a huge topic. It alone, you're gonna learn. If you are in bachelor's, you're gonna see that geometric design itself has first 2 to 3 chapters in your transportation textbook. So that much important, that geometric design, it comprises of horizontal side distances, intermediate side distances, and super elevation, horizontal curves, vertical curves, etc. So you can expect anywhere between two, easily 3 questions from that topic, but sometimes, 2 questions maybe, but in generally you may expect 3 questions from that topic. Okay. Next, payment system designs. So anyone here from transportation engineering, masters in transportation engineering?
Yes, sir.
Yeah, I'm good. So you're from transportation?
Yes. I've recently started my
Yeah.
master's in transportation engineering.
Okay. Oh, so do you talk with any of your professors regarding how, like, what are the researchers going in your field in transportation?
Yeah. I recently talked with one of my Indian professor who is into the
Mm-hmm.
transportation. He's currently
Mm-hmm.
doing research regarding the widening of road and the safety precaution that need to be taken in front of the schools and the hospitals. He's doing research on that.
Okay. Okay. So, as far as my knowledge serves me, I talked with two other candidates who is doing PhDs here. They told me that 85 to 90% of research work is going in pavement design in transportation.
Yeah.
So, yeah, that much important topic is payment system design for your masters, or yeah, Chiranjeevi, in near future you're gonna see some payment related designs in your classes. I hope you're gonna learn that well, and it is a very interesting subject too. So
Yeah, and
that much
also
important. Yeah,
and
go
also
ahead,
in the, in
please.
this in this fall semester, I'm planning to take
Hmm.
payment management system.
Okay.
In that, they told me that that system design will be covered in that topic
Okay. Okay.
because
Make
for
sure
us,
you learn it. You learn it well.
yeah,
Okay.
sure.
Okay. Okay. So payment system design is that much important for your further studies, or or in your masters, or in your for PhD. Some of you planning for your PhDs, or some of you already doing the job in highway field. So, but coming to FE, there is only one formula and one table. You all need that. Okay. So it is very simple. Even though it is a huge topic, but not a huge topic, you'll get 1 mark definitely. If you are lucky enough, you'll get 2 marks. So make sure you don't drop that topic too. And it is very easy to. Next, coming to traffic capacity and flow theory, it is somewhat like huge topic. You need to cover 3 to 4 topics in that area. But believe me, once you understood how it is happening, why, how much capacity it has, how much flow we need to, like in road, what is the flow of that road regarding to the speed and all, it is very simple. You just need to be cautious, more concentrated than any other topic in transportation. So in traffic capacity and flow theory, you'll get definitely 2 questions from that too. So coming to traffic control devices, there are a lot of traffic control devices you can see in your day-to-day life. You can see the light signaling systems, you can see stop board, warning board, indicatory board, boards, and some sign boards, etc. All these types of board, these are all traffic control devices. But for FV, we only talk about 3 things: red, uh, red light timing, yellow light timing, and green light timing. So these three are the only thing we gonna see in traffic control devices. And believe me, you have only 3 questions, 3 formulas. Out of these 3 formulas, you can expect 1 or 2 questions easily. So And coming to transportation planning, it's way more easy, but way more like similar complicated. If you understand traffic planning well, then it is very easy, like soothing subject, soothing topic. You can go anywhere, anytime. You can score that mark from that topic. If you don't understand that clearly, it is a nightmare. So make sure you put some concentration over there in transportation planning also. And believe me, past 4 batches where we taught this topic, no one have complained in transportation planning because they understood well. I gave credits to them also because they had that concentration while understanding the topic. And yeah, so we gonna give 6 classes for the transportation class itself. So in these 6 classes, first 2 classes is dedicated to geometric design. Why? Because we have 3 odd questions from that topic. So we're gonna see geometric design today. And before going to the geometric design, see, I want to go through the handbook once. So in your examination, you can find similar kind of setup in your system. So consider this is your whole screen, and half of the screen you have this handbook like this. Like the in this half you have your handbook, and it's a big screen. Don't worry, this is a small laptop screen, so it's a big monitor. You can see halfway clearly, easily. And in handbook, basically you need to see units and conversion factors. If you ever missed or don't remember how to do something, you can see here. You can feel free to go there and convert your factors, convert your units from here. And yeah, these are the subtopics, side headings or subtopics in our contents in this handbook. Transportation will find you will find the transportation topic in civil engineering module. If you so 299 to 308 is your page numbers for the transportation. This is one type. This is the one procedure um, you can see where the topics lies in. This is the one type. You can simply go to the sections and scroll down where the exact topic you are searching for. Otherwise, you can simply click Control F and type transportation. You can find your the section. You can come to your section. Okay. Even if you don't know, sometimes if you don't know what is traffic signal timing, you got some question from traffic signal timing. So if you don't know where it is and which topic the question came from, you can simply type the exact phase and you'll find the section, or you can find the formula from it. Okay, these are the 2 things you need to see. Like, you need to get through that section easily. And if you find something more interesting, please let me know, or you can feel free to use that. Here my intention is to find out the formula easily without any turbulence, without wasting any time. Okay, so here you can see traffic in the first line itself. You're gonna see queuing models are found in industrial engineering section. So most of the guys omit this topic. They don't know what is queuing model, where it is, and where is the industrial engineering section 2. But fortunately, once in a blue moon, you can see some question from queuing models that is mostly dedicated towards industrial engineering section. So that's why we don't see questions more often. But we don't want to lose that mark too. We'll see that queuing models also how much we required from that section. in our last class. It is related to traffic planning. So we'll discuss that queuing models also in our last class. Okay. You can see traffic signal timings, yellow light, red light, and green light, stopping sight distance formula here, peak hour factors, and vertical curves, horizontal curves, and horizontal curve special things in horizontal curves, and basic freeway segments. In this topic you may expect a direct question. They don't play around with units in this topic particularly. And traffic flow relation, green shield models, gravity models, crash reduction, safety factor, safety traffic safety equations, and pavement design, what I told you earlier, the traffic highway pavement design. So these are the table and formula for the structural number. So from 299 to 308 is your page numbers for all your transportation engineering section. Okay. So now our first topic is geometric design. Okay. Going to what actually we are looking today. Our first topic is stopping sight distance. So let me ask you a question. Imagine yourself, you're driving in a highway at some certain distance, like 200 feet or 300 feet prior to you, you're traveling at 60 miles per hour in your car. At 200 to 300, 200 feet away, you saw one truck halted, or some accident happened, or some truck halted. Um, so imagine you're driving in a highway like this. You are here, your car is here, your car is 60 miles per hour or some or speed. A truck has halted like this. You don't have any space to move around. What will you do? So what will you do? Just this is the scenario. You are driving a car, you are in a neat good highway without anyone. It's a pleasant day, no one is on that time. There is no way escape possible. There is no way to turn around and go around that vehicle. What is your first thing you'll do in this situation?
Slow down
I'll
our
take someone. Sorry.
slow down our vehicle.
Oh, Lakshmana Suresh, are you
Yeah,
answering this question? Yeah.
yeah.
Okay. So what will you do?
It's slowing down,
Okay, slowing down, then
and gradually slowing down the vehicle, and at the point of time we will stop the vehicle.
Slow
stop the
down and
vehicle. Okay.
apply the
We apply some
Slow
brakes
down
to
and you stop the vehicle. Yeah, Vishal?
Can we change the line? Slow down and
No,
take the second line.
consider this is a two lane. Even consider this is a like one-way highway, but you have some multiple lines. But you can see this truck is like cross the horizontally, and you don't have any space to go around.
We're gonna apply the brake.
apply the brakes to stop the car and call cops.
Okay. Calling cops is a different scenario. Yeah, it's good. You need to call the cops. But our
We can
first,
apply emergency
whatever you
lights and we can just stop on the backside of this vehicle.
Yeah, perfect. So here the stopping the car is our prime agenda, but our goal is to not to hit the truck. You need to stop the car before your car hitting the truck. Okay. You need to stop your car before hitting that truck. That's your prime agenda. So in this situation, you're driving like this. You suddenly seen that truck is over there, and you don't have any space to move around. So first thought of you is, am I able to stop my car right now? That's your thought. First thing is your thought. You see and you receive the information. You're seeing that there is a truck, and your eyes send that information to your brain, and your brain think, yeah, in so and so distance, in certain distance, it have around 100 to 200 feet. I can stop my vehicle by braking now definitely without hitting that truck. So this brain processed that thing and made one decision in your brain. Then this brain tells conveys a signal to your foot saying that press that brake immediately. So that is reaction. After pressing the brake, the vehicle gradually slows down and it will stop up after some distance. Okay, and you are traveling and make sure at that point you see the truck. This is your first contact receiving the data. This is your first point. From by seeing that truck at that moment to applying brake, that is your braking time. And in that braking time, even before you hitting the brake, after receiving the information that you have a truck in front of you, you need to brake and you need to slow down. This time, what are the thinking time and reaction space, you have some time. So that is called perception reaction time. That perception reaction time is 2.5 seconds. If in question they gave, if they gave the perception reaction time is 2.5 seconds, some 3 seconds or 2 seconds, it's okay. If they don't give you the perception reaction time, then it should be 2.5 seconds. Okay, this should be you need to remember this one. And my question, you can see 1.5 seconds for perception and decision. 1.5 seconds, it will take 1.5 seconds to you to see the situation, understand the situation, and make the decision in your brain. For this whole thing, it will require 1.5 seconds and 1 second for your reaction after making the decision in your brain. Your brain sends the signals immediately to your foot and applying the brake. For this, you require 1 second for your reaction. So overall, your perception reaction time is 2.5 seconds. And yeah, Priyanka,
Mother.
do you believe perception reaction time varies from person to person? Like if you're if you're in your 20s, and if you're in your after turning your or your mother or someone driving the car, she is maybe 50 years old. Do you think there is a difference in perception reaction time for you both? Like what you think you have? Do you
Yeah,
have lesser perception reaction time or your mother?
I think we do lesser perceptions, reactions like timings than older ones, I think.
Yeah, perfect. Why? Because like older guys, they have they have greater reaction time. Even before even we have the like what we call, they'll see the appropriate situation, they understand the situation in perception decision making time is maybe similar to both of us, like both of persons in 20s and 50s, but reaction time would may be different. That guy may take 1.5 seconds in that condition. So perception reaction time varies from driver to driver. So you cannot remember, like say 2.5 seconds idle for everyone. So it may differ, but for FE, if they given that time, it's wonderful. Okay. If they don't given the time, it 2.5 seconds. Okay. So here the condition. And so here the car, you've seen a person. At this point of time, you've seen this lady walking around and you thought she's a some mad person or something like that. And you thought you need to stop without hitting her. So that you've seen here this lady, and you thought there is something bad about and you need to stop. This decision making in this 2.5 seconds, this is your perception reaction time, you got 2.5 seconds. Okay, in this 2.5 seconds you travel some distance. In that 2.5 seconds also, you'll travel some distance. That distance is reaction distance. And after here, coming to here, you reacted and you applied brake here. After braking, the car will slowly decelerate and stopped here before hitting her. So this is braking distance. After you applied your brakes also, you travel some distance. That distance is called braking distance. So this whole thing from starting, you seeing one obstacle or something you need to stop, from that object to this point where you seen that object is called stopping sight distance or stopping distance. In general terms, we call it as stopping sight distance. So this is why we need to provide such a distance, stopping sight distance, to eliminate the accidents. So that's why we place some stopping sight distance from in our highway. So how we place, if you're consider you're driving in a highway, there is a that terrain of highway is like this. If you are here, you can from here, if the stopping sight distance of this highway is 200 feet, that means at any point in this highway, you may be here, you may be here, you may be here, you may be here or here. Any point in this highway, you can able to see 200 feet in front of you. If there is any obstruction, minimum 200 feet, you need to have that space to stop your car without getting without involving into an accident. So that's the main theme of stopping sight distance. Okay, so here 1.47 vt is your reaction distance. Okay, 1.47 vt is your reaction distance, and v square by 30a into 32.2 plus or minus g is your braking distance. Okay, let me ask another question here. So you can see v is design speed in miles per hour and my t is driver reaction time in seconds. Okay, so here my question, do I need to change my design speed miles per hour into feet per second square or feet per second? Do I need to change that? If yes, why? If no, why? Volunteer yourself, make a guess. There's no problem. If you done something wrong, you're gonna learn.
Yes,
Who said yes?
this is Akhilesh.
Akhilesh? Okay. We need to change those options, Akhilesh.
Yes,
And let me make another clear thing here. This one I took from handbook. Even if you see in your handbook also, this is the exact imprint. You can see here, you can see in your handbook too. So
okay.
handbook says we speed in design speed in miles per hour.
So that SSD is in distance, right?
SSD, ultimately SSD you can come across with feet.
Feet, yeah, like yeah.
Yeah.
So if we have miles per hour and then second, I don't know if that cancels out on its own.
Mhm.
So if we need to have that in feet, so
Okay. So your stand in this, you need we need to change that miles per hour into feet per second, right?
I
Yeah,
mean
Akhilesh, you're
per
saying that
hour, mile,
we need to change design speed in miles per hours to feet per second, right? Yeah, no
yes.
hurry. There is nothing like, even if you done wrong, it's fine. Don't worry. Anyone has any other call? Pawan, Hassan, Mush.
No, sir, we should not change accordingly as per the given. Like we need to submit them in the mile per hour.
Yeah. So
Because
why we need to?
after submitting of the values, like if we consider that the velocity is in the meter per second, after converting them into the meter per hour, like substituting the values over there, then only we will get this standard formula. Like I'm not getting that word empirical or standard. Yeah, we will get this formula.
Okay. Perfect, Renuka. And I appreciate Akhil for your answer, because most of the times, most of the guys can thought in that way. Okay. And here the thing, why we are not changing miles per hour to feet per second is, you can see there is a term called 1.47 here. 1.47 here. This 1.47 is a factor which gonna change your miles per hour to feet per second. So you don't need to insert again. You don't need to change this miles per hour to feet per second. So apply like or input that whatever the design speed in this formula without changing to your feet per second. Okay. And second question, second thing, you can see here A is not acceleration. It is actually deceleration. Why? We are applying brakes. We want to stop the vehicle. We are not accelerating the vehicle. We are stopping the vehicle. So in this situation, deceleration, A is deceleration. So most of the times, students mistakes that A is misunderstood that A is acceleration, and they place A as 11.2 something. We have 9.8 feet meters per second square, some value they randomly remember from their 10th class physics or from bachelor's. Actually the gravitational pull, they insert those value in acceleration. That's not the case. Or sometimes they convert those what we call velocity or speed into feet per second, and they input that in acceleration. So there is no dynamic part involved, there is no gravity part involved in this. So A is actually deceleration. If it is in D, it should be make more sense, but what it is. So it is A is deceleration, don't confuse with that. And coming to G, what is G? So G is actually percentage grade of that road. If you see, this is a straight road, there is no percentage grade. If this car is traveling in slope like this, here, if this stopping side distance in a what we call zero slope road, my stopping distance, if it is 500 feet, thus in this condition, my stopping side distance is going to increase or decrease?
Increase.
Increase.
Perfect, Akhil. Why it is increasing?
It's
Gravitational force.
They have degree of force increase.
Go on. Yeah, somewhat correct.
Because we are going downhill, right?
Perfect. So Sharif, absolutely correct. So consider yourself, you're traveling in a car in a downstream. So if you're traveling like this, even though if you're don't pushing your accelerator much, that car will go keep on increasing that speed. Why? Because it is on a downstream, like downgrade. So if you are traveling in a up level, the stopping side distance would be lesser, because the grade itself obstruct the speed of or acceleration of that vehicle. So in that situation, if you apply the brakes, the braking distance would be very lesser, and it require very less distance to stop your car. So that's why if you're traveling in a what we call upstream, like upside,
Uphill, downhill.
like this, yeah, like this G is plus, and if you're traveling in downgrade, it is minus. So if the denominator is getting lesser, then your overall quantity or the division value is going to higher. So in that condition, your stopping side distance going to have greater stopping side distance. If you're traveling in this condition, your denominator get increasing, so that overall product of this calculation gonna decrease, and your stopping side distance gonna lesser than what it is in normal slope or in downhill. So, and another thing you need to cautious here, G, you should always, it is a percentage grade. Sometimes he says 4% uphill, 4% uphill. That doesn't mean you're gonna place this G as +4. You need to place 4/100 or 0.04. Okay, make sure you take this value correctly by dividing bit by 100 or taking it as a percentage, not as a factor, or take as a not as a whole number. So that's the one thing you need to remember here. And in some questions, he asks you about what is the reaction distance. In such time, you don't need to calculate this part. You simply eliminate this part. This is the only thing he is asking you. In some other question, he may ask you what is the braking distance. He don't care about reaction distance. So in that condition, you can rule off this, and you can you need to calculate this only. So this is the whole thing about stopping side distance. Do you have any questions, or anyone have any problem understanding this? We'll move into
Can you
next topic.
Okay. Please give a quick rundown of units, just units,
Just
units of
units?
units of every variables here.
Okay. So V is a design speed. It is in miles per hour. It should be miles per hour. And reaction time T, driver reaction time T is this one is T, driver reaction time. It should be in seconds. And axis A is deceleration. Deceleration should be in feet per second square. And G is percentage grade. It either need to divide it by 100, or it should be in this type of factor. And
No units,
ultimately you will
just a magnitude for G. Just a magnitude,
this
no
not
units, right? Okay.
yeah, because for a grade you don't have any units. For percentage you don't have any units, right? And ultimately you'll get stopping side distance in feet. Am
Okay.
I okay? Are you okay, Sharif?
Yeah, I'm okay. Like I was just curious how MPH got cancelled here.
Yeah, this miles per hour will automatically convert into feet. This miles per hour and this miles per hour automatically, for this you can see here in this situation, this miles per hour automatically convert into feet per second by using this 1.47 factor. Okay, and
All
this
right.
this miles per hour automatically like convert into feet per second with this 30 and 32.22.
All right. Thank you.
You mean feet,
So
right?
I believe no. Yeah, Akin?
You mean feet?
Yeah, 2 feet.
Oh, yeah.
I believe no one have any questions further, so I'm moving to next topic. If you have any, please feel free to ask me right now. Okay. Okay, we have another 10 more minutes. So this is intermediate side distance or intersection side distance. Most of the times you will see as intersection side distance, but I got this intermediate side distance name too, because sometimes you may see this also. So I don't want to like omit anything. So intermediate side distance or intersection time, intermediate or intersection ISD. Okay, so make sure you know this one. You keep in your mind this intersection or intermediate is the same. Okay, so actually what is the concept behind this is, in a if you're traveling in a major road and there is some connection roads too, so if you are traveling in a major, like in this stream, if you are traveling in a main road, you have higher speeds than this guy. And if you are traveling and at this moment, like some x distance, let's say 15 meters, you'll find a hazard, or you find another car who want to join in this stream in lesser distance. You can find, even if you are 15 meters away from this intersection, but this site radius is just 6 meters. From here, you can only when he is 6 meters away from that intersection, then only you will able to see this guy. Why? Because there is no sight aspect from longer distance, because this all vision is blocked by these unwanted materials, even maybe some trees or some buildings or some etc bushes etc. This vision got blocked before you don't have any clear vision for this road. So you may able to see this guy just 6 meters before he is entering into intersection. In this condition, if he is also in some good speed, he want to join this stream or he want to go like this, you definitely hit this guy. So this is not allowed. This is very dangerous in intersection, near intersection. So we in this concept says at least you need to maintain some 30 meters or plus sight radius, so that with the same length, with the same 15 meters away from this, not 15 exactly, with same minimal distance, you need to see this guy, so that either you will slow down, if it is an ambulance or something, you will slow down, or you'll take faster route, you'll accelerate yourself and merge into other, like avoid the accident. So this is what intermediate side distance or intersection side distance says. So in this condition, we only consider V major. V major is you only think about this guy, because in this intersection he'll definitely gonna have lesser speeds compared to this guy. So the major problem for the vehicle to stop is this guy. So we took V major, that is speed, design speed of major side of the road, and TG is time gap of the vehicles entering into roadway. So this time gap between these two, so it should be higher. So at least 3 or 4 seconds, I think, because in some questions they'll give some books they give 3 seconds minimum, and in some books they give 4 seconds minimum. But for FE, they definitely give you the TG time. Okay, so if you get any question from intermediate side distance, intermediate or intersection time side distance, it is a freebie for you. They are expecting you to get 1 mark. They are giving you the mark. So if you are lucky enough, you will get this question. And intermediate side distance is 1.47 V major by TG. Make sure you inserted, like you calculated with major side of the main road vehicle speed, not the intersection speed. And TG, they definitely give you 100% sure. They'll give you this TG. If they miss, they'll give you the ISD, intermediate side, intersection or intermediate side distance value. By giving any two variables in this formula, you can find easily another one using one formula. So anyone has any questions in this topic?
Yes.
Yeah.
So you said
yeah, Astra.
This V major and V major is the design speed of major road, which will be, it will be there in the question, right?
Yeah.
You mean this 3 to 4 second, which you said here? Is V major?
3 to 4 second is, that should be the gap for each vehicle enter into the intersection. So if this guy is in a higher speed, always this guy is in higher speed. Why? Because he is traveling in a main road. So after this guy entered or like entering means this stop. At this position, this guy should not enter here. After this guy enter here, there should be 3 to 4 seconds gap this particular vehicle to come here. So that's the time gap for vehicle entering roadway. Why? Because if he is here and there is no the time gap is 1 second, then in that 1 second this guy travels here and this guy travels here, collision happens. So ultimately our transportation, we are dealing this subject just to avoid these mere accidents. So that's why this time gap between these two vehicles at least 3 to 4 seconds to avoid that accident, collisions.
So,
Yeah, sir.
I mean, I'm trying to understand what is V major here.
Yeah, V major is the design speed of this road, main road. Design speed of this major road, this main road.
Excuse me. In this
Yeah.
question, are we specifically talking about any specific vehicle, or is it the general, like for every vehicle, if this enters in the
Yeah, it's
intersection?
general. It's dealing about it's not about the vehicle speed. It's generally talking about this road speed.
Intersection.
Yeah, this road speeds. You have consider yourself traveling in some highway. Okay, this is a 4-lane highway, and you are here. And at this intersection, you have a small village road which is coming into this road. Okay, so if you are here, what you'll do? Do you maintain high speed or low speed?
Lower speed.
Why? Because this road is a village road and it is very small width and all. You'll definitely maintain lower speeds. But this
Yeah.
is a highway, and this in this, if you are in this vehicle, you'll maintain a higher speeds,
Hmm.
right?
Right.
And if you are in this vehicle and you probably see this guy a way before, like very much here, and you
Hmm.
think at this speed he can join this line, you'll definitely slow down and give a way to this guy.
Yeah.
If
Right.
you find like 4 to 5 seconds gap between you and this guy. Otherwise, what happen? You'll come fast, and if he is also not maintain some basic things, definitely collision gonna happen. So to avoid these things, we take this V major as design speed of this highway. Okay, and time gap between entering the vehicles is this guy to reach here and this guy to reach here. After this guy reaching here, sorry, after this guy reaching here and to this guy to reach here, the time gap should be 3 to 4 seconds in minimum in general. So that's the case in intermediate or intersection side distance. So don't worry if you have some question regarding this, how this happening and all. It's just
One more
a simple formula.
So it's
In question
1.47.
also. Yeah.
This 1.47 is a constant.
What is 7.47?
No,
One-
he asked
1.4.
1.47 is the constant or
Yeah,
not?
yeah. 1.47 is the constant. 1.47 is the constant which converts this
Factor.
miles per hour into feet per second.
Okay. It's just a conversion factor.
Yeah, conversion factor. Because for miles per hour, if you change your miles per hour, where is this? If you change 1 mile is equal to 5240 feet, I think, and 1 hour is equal to 60 into 60 seconds. By cancelling out the miles per second, you'll get this 1.47 something. Let me check that.
Thank you.
I think it's
Yeah.
5280.
Yeah, 5280 divided by 3600 is 1.4667. So you'll get one by doing this, it is 1.46667. So for our convenience, it is 1.47. So this is the conversion factor. Okay. So today we are going to see. So again, coming to your horizontal curves, I believe no one have the question, any doubt in intermediate side distance now? if you have any question or some ambiguity in this topic, um, then nothing to worry, because this V major in these three terms, 1.47 is your conversion factor. That is constant. You don't need to be worried. V major is your design speed of the major road. This major road, that definitely gonna see in your question. If there is two speeds, which in your question, the higher speed is your V major. Okay, and TG is the time gap interval between vehicles entering into the intersection. This time definitely they're gonna give you in the question. So there is no way you're gonna mistake. You're gonna do something wrong in this question until and unless you made some mistake with your calc. So make sure you practice well with your calc without doing any mistakes. Okay. So coming to the horizontal or simple circular curve, we all knew what is a horizontal curve. Horizontal curve look like this. When you are traveling in a road, you'll find this n number of horizontal curves. So for a horizontal curve, this is the actual scenario you'll see in a road. Right now we are seeing from the top view, not from the what we call front view or cross-sectional view. We are seeing from the top. You are seeing this road from the top angle. So consider there is a straight road and there is a straight road here. So you want to travel from here to here. If I laid a road like this, it is impossible for you to turn a 90-degree bend here at certain speed. You're definitely gonna end up with an accident. So what engineers, like previous engineers done, and they studied and they made a thing. This is a straight road. From here to here, we maintain some tangent, which gradually decrease the, like, turns the vehicle. Here also same. And they made a curve, circular curve with some radius. They made a curve, and from here, this end point, here they again made one tangent. We have one tangent, and again this merge into this straight road. So for this, for a simple circular curve, what are the things we need to have? For basic 4 things we need to have for the simple circular curve is constant radius. We have that. And tangents, we need to have 2 tangents. One is at beginning. You can see one is at beginning. One is at beginning. One is at beginning. And one is at end after the curve. Okay. Then point of intersection. This is an imaginary point. This point of intersection is nothing but from this tangent. I continue my tangent as an imaginary plane. I continue this tangent as an imaginary plane. This meeting point, this both tangents meeting point is called point of intersection, PI. We have some angle here that is called intersection angle. So the next, what we need to do, curve length. Curve length is nothing but this is the curve length. This one from here to here is called curve length. Okay. So, and we have one thing called PC. This is a PC is nothing but point where tangent ends and circular curve starts. Curve starts. That is PC. PC. PT is nothing but point where curve ends and tangent starts. You got my point? So PC is where tangent ends and curve starts. PT is where curve ends and tangent starts. So tangent ends and curve starts at this point, and at this point curve stops and tangent starts. So these are the 2 points, PT and PC and PT. Okay. I have one PI. Sorry, Sharif.
No, I mean vice versa. This and that stop, that and that stop, like, you know.
Yeah. For instance, we are traveling from left to right. So our first point is PC. But in construction, we got one point we we consider one point as a starting point. That starting point is PC point. Why? Because we know here, we know what is the tangent slope and what are the radius we need to maintain to meet this another road. So in practically, we know this road tangent, we know this road tangent, and we know the radius of the curve. So this is the starting point of the curve. So using this radius, we draw a circular curve, and after this curve touches this point, we consider this as a PT point, ending point. So that's why this is a PT point. So that's why we consider PC as a point is a starting point. Okay, and curve length is this is the curve length. So based on this, Pi plus this imaginary tangent where we elongated or we drawn further in this imaginary line using this tangent slope. This is also tangent length here. This pi station means we have some length here. Let's say this is 100 feet, this is 50, and this is 150. Okay, this 100 feet, this station plus this tangent length is pi plus tangent is equal to PC, but not equal to PT. Okay, pi plus tangent is equal to PC, but pi plus tangent does not equal to PT. Why? Because from starting point we know the tangent, we know what is the tangent, and we know what is the starting point. So in this condition, we don't take this also. We don't take this equation also. So that's why PC, but anytime Pi plus T, or sorry, Pi minus T is equal to PC, and PC plus L, whatever the length of the curve is, gives you PT. Why?
Sir,
We know the we know the just a second, Sharif. So
Miss-
we know the starting point. This is fixed, but we don't know where it is ending. So that point where it is ending after the total length of the curve. So that length accounts here. So Pi plus T not equal to PT. PC station plus length of the curve gives you PT, and Pi minus T is equal to PC. But this is not that much important here, because we always know PC values. But make sure you knew this. But this one is very important. This one is very important. Pi plus T not equal to PT. You always need to understood that from starting point we draw the curve with radius. We don't know the ending point. We know the what we call a road where we don't know where we gonna touch that point. So that's why starting station plus length of the curve is equal to PT station, end station. Okay.
What's
And
minus T? I didn't get the point. Pi minus T.
Okay.
The second
Okay.
equation.
So this is the Pi point. That means imaginary tangent point of intersections. Okay. This is an imaginary point which we drawn by drawing the tangents with their same slope. Okay. From this point, we have certain distance. This is, let's say, in this road, you can understand here better. So I consider I have a Pi point here, and you're starting, this point is 0, and traveling like this and ending here. This is a PT point. Okay. PT, PC, and PA. Okay. This is the tangent. I got this point as 100 feet, like this point as 100 feet. And this tangent is, let's say, 30 feet. Okay. 30 feet. For getting this PC value, 100 minus 30, like Pi minus T is equal to PC. Okay. But you know there is a one tangent here. This tangent is 30 feet. So can I write pi plus 30 is equal to pt? Sorry, pi plus t is equal to pt? No, this is wrong. Because why? Because we know the starting point, we don't know the ending point. That's why we are
Got you.
getting the curve here. So that's why pi minus t is equal to pc. It's fine, but pi plus t not equal to pt. pc plus length of the curve is equal to pt. Okay. So these are all the equations we're gonna have in our handbook. Radius and degree of curve, radius with respect to long chord, tangent with respect to long chord, tangent with radius with respect to degree of curve, radius with respect to long chord, tangent with respect to radius of the curve, tangent with respect to long chord, length of the curve with respect to radius and intersection point, or intersection angle or degree of the curve, mid length of middle ordinate. Yeah, perfect. So length of middle ordinate with respect to r. So these are all the equations. You'll have this in your handbook. So one thing you need to understand, that which is the better option and which one is the better formula in a given time. You need to figure out that. We'll see some questions tomorrow on the first instance, like first 15 to 20 minutes. We'll see some questions on this. We'll discuss what is degree of curvature tomorrow, and super elevation, horizontal sightline offset, spiral transition curve, and some vertical curves too tomorrow. So maybe I believe tomorrow we gonna end up with horizontal curve problems and theory of vertical curves too. We'll complete the theory of geometric design tomorrow. And thank you for giving additional 10 minutes for me today. And I'll make sure guys will give the link in our group in before 5 to 6 minutes earlier prior, so that you can join without any turbulence, so that I can start my class here at the 9 o'clock, as we all are agreed for that. Okay. So do you have any questions for today? Yeah, Pravalika, Varshini, Venkat, Harsha, Mujbullah. If sorry if I pronounce some of your names wrong. Sujat, Omar, Pawan, Ahmad, Sadiq, Lakshman. Anyone have any questions?
I wanted to ask, are we getting compound and complex curve in the FE exam?
No. You only restricted for we only strict for curve, horizontal curve, like simple circular curve, not the spiral like that compound curves. We don't see that one.
Okay, so in this case, the question will be mainly finding the capital D or a small d, right?
No. You can expect to find PC, PT, PI, tangent length, middle ordinate length, length of the long chord length, whatever they give, radius, D.
Okay.
You are expected to find all of this. So don't worry, it is straightforward, pretty much straightforward. They'll give what they want you to find. Pretty much straightforward questions. There is no twist and turns over there.
All right, no problem. Thank you.
Yeah, thank you, Samir. Have a good one. Yeah, good night. See you tomorrow.